Okay, let's dig into this idea that I mentioned in the previous section of thinking about sounds as being characterized as sets of phonological features. So we mentioned above for the phoneme of a voiceless alveolar stop in English and German that it would have some, it would be a sound consisting of some of these phonological features and more. And let's try as a first example here to make a detailed representation of the English word cat using the complete set of Bayesian features. In this case, and in general, we can think of all of these international phonetic alphabet symbols that we use to represent the phonemes of a given language as sorts of abbreviations for matrices of features, for groups of features that characterize these sounds. So, for instance, the sound ka is characterized by all of these features here. For instance, it's not syllabic, so these two consonants are non-syllabic in contrast to the vowel a, which would have the feature plus syllabic. And these stops in English are both specified underlyingly as having the feature minus spread glottis, indicating that they are by default, that this phoneme is a non-aspirated stop. And we have the features written in capital letters here refer to the three major places of articulation: labial, coronal, and dorsal, which we'll say more about in a minute. So there's a big set, a large number of features that we should assume for any given sound needs to be specified as having a binary value, plus or minus. So one question that might arise if you look over onto the feature charts that are provided in Hayes' textbook beginning on page 95 for the consonants. It's his table 4.7. There are some features in this table that I haven't given in these feature matrices. So for instance, the features anterior and distributed, which have a column in this feature chart. Here's anterior, and here's distributed. Talk about what those mean in a little bit. Those aren't present in this feature matrix for the sound ka. Why is that? So the reason is that there are certain features, and in particular the three major place features, labial, coronal, and dorsal, which automatically entail some particular values or which are consistently totally neutral with respect to other features. So for instance, a sound which is non-dorsal, which is minus dorsal, can't ever have a value for the features high or low. So here we can explicitly contrast this dorsal stop ka, which is plus high and minus low, specifying how the tongue body is positioned, whereas this coronal stop, ta, because it is minus dorsal, actually I think I've forgotten the feature minus dorsal in here, but in any case, because it is minus dorsal, of course, it will have no value for the features high and low. And that's essentially what this 0 in the Bayesian feature charts means, that that sound can't be specified for a value for that feature. And we'll talk a little bit more about what relevance 0 values end up having in writing phonological rules later on. Now, in English, for instance, a lot of the features that we've given here as saying that they are part of the definition of these sounds for English, they are for the purpose of identifying those sounds, just trying to build natural classes of single sounds. So if we want to make a natural class just of ka or a or ta in English, we don't need to use all of these features. It's sufficient. It's sufficient to use some smaller set of features. So for instance, for most varieties of English, to find the stop ka, it's probably going to be sufficient to use the just two features plus dorsal and minus voice. Ka is probably the only dorsal phoneme in most varieties of English, which is voiceless. So those two features would be sufficient for identifying this natural class. Let's take another example now of how the features that we see here in these matrices are relevant for the construction of phonological rules. So let's consider a rule that we would need, which we've referred to above under examples 5 and under example 5, in order to create aspirated stops in English. So as a first approximation, let's say that stops, voiceless stops in English, become aspirated at the left edge of the word. Conditions are actually considerably more complicated than this, but for present purposes, this will be enough. Here, we'll use the feature minus delayed release to identify stops in English. We'll see that this feature in general is used for identifying stops in the Bayesian feature system. Just to take a quick look as an example here, if we look at the stops pa and ba at the labial place of articulation, these are marked as minus delayed release. And if we look down to dentals and alveolars, the two dental stops, ta and da, and the two alveolar stops, ta and da, also marked as minus delayed release. And this rule specifies that, okay, when we have sounds which are minus delayed release and minus voice in English, they become plus spread glottis. In other words, they obtain longer voice onset time, aspiration, when they're at the left edge of the word. So this rule will look for some segment that contains the features of the target, which is on the right side here, and it will look for it whether it occurs in the correct environment, namely whether it occurs at the beginning of the word, and then applies this set of changes, which is specified here, saying that the targets become plus spread glottis. So in the case of the word cat in English, a possible target is going to be this underlying phoneme ka, and it will be targeted because it bears the feature values minus delayed release and minus voice, which I've put in bold here. And because it stands at the left edge of a word, it's going to become plus spread glottis. The feature value, the value for this feature plus spread glottis will change from minus to plus then under those conditions. So we would say that the underlying representation, the underlying form of the word referring to this class of felines is going to be realized with aspiration of that stop at the left edge of the word by the application of this rule. Okay, before we begin to start working systematically through the Bayesian feature system, I'd like to make a brief detour into the origin of phonological features, where these terms come from. So this is a bit of historical background. So to my knowledge, and work to develop a comprehensive system of phonological features goes back at least 70 years or so. There's an important paper by Roman Jakobsen, together with Morris Halley and the Swedish phonetician Gunnar Fant, on an early version of a contrastive phonological feature system. Also, Morris Halley's 1959 book, The Sound Pattern of Russian, looks into feature systems, and there's then a further development of ideas on feature system in Chomsky and Halley's 1968 Sound Pattern of English. However, over the course of the past 70 years, developing a distinctive feature system and an overall theory of distinctive features has been somewhat difficult, and there remains some degree of disagreement between scholars, and there are different versions. In virtually any textbook, any introductory textbook on phonology, you will find some amount of divergence in terms of features. Now, here we can, I'll briefly mention one view that is contrary to a kind of, we'll call this an anti-innatist view, which supposes that all phonological features are learned by children undertaking language acquisition. And under that theory, we would not necessarily expect for different languages to make use of the same features. But one objection to this idea would be that many languages seem to be effectively described using essentially identical features. So if features are not, to some extent, inborn, then the fact that we have so much similarity in phonological behaviors might be somewhat surprising. Concerning the system that is presented in Chapter 4 of Hay's textbook, my assessment is that the majority of the features that are used there could be called mainstream, in the sense that they are largely agreed upon by most phoneticians and phonologists as at least plausible, if not extremely likely or virtually certain. Here, if you briefly compare the features that are used in Hay's textbook versus Hall's textbook, you'll find that some of these features are virtually identical. Sometimes the name is a bit different, given the German language terms that are used in Hall's textbook, but you can regard those features as identical. So for instance, the features consonantal, sonorant, and continuant, which correspond to konsonantisch, sonorantisch, and kontinuierlich in Hall's textbook, those refer to the same groups of sounds. In some cases where I've given a dash here, there is no correspondent in one or the other word. As you can see, the Hay's feature system is more detailed. So particular in terms of manner features, Hay's has more features which are not present in Hall's book. Hall's book doesn't use the features syllabic or delayed release or tap or trill. Though Hall uses one feature, radical, to refer to consonants like pharyngals, which are articulated kind of with the tongue in a very deep low back position. So he adds another major place of articulation next to labial, coronal, and dorsal. But by and large, you can see that these feature systems mostly agree with one another. So to get some idea of how phonologists arrived, since we can see that Hayes and Hall, for instance, agree on a lot of these features, well, what has led a lot of phonologists to agree on a lot of points that, oh, we need to identify sounds which we'll call sonorants and sounds which we will call continuants, for instance. So the theoretical assumption, the underlying theoretical assumption here is just that if there are two sounds in a language which are contrastive with one another, two sounds which are phonemic, then those two sounds need to differ in terms of at least one feature. So for instance, most varieties of Spanish distinguish between a tap, ra, and a trill, a rhotic trill, ra. This would mean that we need some kind of feature to distinguish between them within the context of the Spanish phonological system. Both of those sounds probably need to be identified as approximants, as continuants, as sonorants, but those features alone are not going to suffice to distinguish between these two sounds, between a tap and a trill. And precisely for that reason, I think Hayes introduces these additional manner features of tap and trill. And looking across the phonological systems of the world's languages, if you find a rule that groups together some set of sounds, then, and if those sounds are grouped together either as the target of the rule, so on the left side of the rule, or as part of the environment for the rule on the right side of the phonological rule. And especially if we find those sounds recurring in multiple different processes across multiple languages, then we have good reason, good empirical evidence that those sounds constitute a natural class, and we would want to find some feature to describe it. So for instance, if we find that a lot of languages add nasal airflow to a vowel, so for instance, this is pretty systematically the case in most varieties of English for vowels which are followed by a nasal. The vowels of English are actually fairly heavily, in many varieties, fairly heavily nasalized in that context. Then this would mean that we need some feature to capture the natural class of sounds like and And throughout, as we'll see, as we systematically introduce those features, it's going to be sensible to think of the features as being articulatorily based. So having a basis, being grounded in the way in which the sounds are produced. So the perspective of phonology in these feature systems is the perspective of the production of sounds generally. And so we can think of, as I think I mentioned already, it might make sense to think of these phonological features as being sort of commands, orders to muscles, to articulators in the mouth saying, okay, do this with the tongue, the lips, etc. Though there are a few features instead which are acoustically based, that are grounded in the way something sounds rather than exactly the way it is produced. That's the case, for instance, the feature strident or sibilant. Okay, good. So let's take a short break here, and then when I return, we'll start looking into all of the details of Hayes' feature system.